You know that feeling, right? You've spent ages working with your AI assistant, you've got this great flow going, solving complex problems. Then you come back a week later, ask it about that same project, and blank stare. Like it never happened. Total memory wipe. It's incredibly frustrating. Well, today we're diving into one developer's truly epic story, sometimes funny, often painful, trying to fix exactly that. Trying to give his AI partner, Nova, a proper long-term memory. This is going to be a deep dive into a real first-hand account. We're talking ingenious ideas, soul-crushing roadblocks, and honestly, a twist ending that might just change how you think about working with AI. Our mission here is to pull out the key lessons from what the developer himself calls the RAG project from hell.
And that core issue, like you said, is the AI's, well, shockingly short memory. It comes down to something called the context window. Think of it like the AI's active working memory. It's desktop space. It's super efficient for what's right in front of it, but once a conversation ends or gets too long, poof, anything not on that tiny desk is gone. This isn't just about remembering old chats. It's about enabling the AI to actually build on past knowledge, to grow with you, to become less of a tool and more of a genuine partner.
Okay, so let's get into how this developer at Nova first tried tackling this. Their initial approach sounds almost quaintly simple. Nova would summarize each session, and the developer just pasted these summaries into one big, growing text file.
Right, simple on the surface, like no fancy tech needed, but that simplicity didn't last long.
Yeah, I had a feeling. What went wrong?
Well, as the developer put it, it quickly became untenable. That single text file just swelled. We're talking over 120 pages of really dense, summarized text. And the problem wasn't just the size. Feeding this monster log back into the chat didn't just make Nova slow, it actually made her worse. It actively degraded Nova's ability to think. It was like she was drowning in this huge, messy pile of her own memories. It shows raw data isn't memory, not without structure.
Okay, so the giant text file approach was a bust.
Yeah.
Suffocated the AI. What was attempt number 2? Sounds like they went a bit more technical.
They did. The next logical step, very developer-ish, was converting that whole 120-page history into a static HTML file. Put it on a server somewhere. The idea seemed perfect. Just give Nova the URL and her system prompt, her instructions, and she could just look it up whenever needed. A neat, tidy external brain.
Ah, finally. A digital library for Nova. Simple, elegant. But I'm sensing another roadblock coming.
You're sensing correctly. They hit a really common and really frustrating wall. Nova's built-in security rules. Her core programming just wouldn't allow her to access external websites directly like that. It was a flat no-go. And this raises a big question, doesn't it? About how these AI systems are built. They live in these secure sandboxes, which is good for safety, but it can really limit how we, as users or developers, can extend their capabilities. Who's really in control?
Right, the classic security versus flexibility trade-off. So they're stuck. The simple text file failed. The web link failed due to security. Feels like a dead end.
It really did. But then, almost like fate, an email lands in the developer's inbox. It's from Google, talking about a new model called Embedding Gemma.
Embedding Gemma. Okay, that sounds promising. What was special about this? Why did it feel like destiny?
Well, this model was designed specifically for something called Retrieval-augmented Generation, RAG for short.
RAG. We hear that term a lot now. Can you break that down simply? How does it help with the memory problem?
Sure. So RG basically gives the AI access to an external knowledge base, like an external brain or library, without needing to cram everything into its limited context window. And the key is those embeddings that Gemma creates. Think of an embedding as like a unique digital fingerprint for a piece of information, a sentence, a paragraph, whatever. It captures the meaning, the semantic essence, not just keywords. So you take that massive 120-page log, run it through Embedding Gemma, and create these fingerprints for everything. Store them in a special database, a vector database.
Okay, so you've got this library of meaning fingerprints. Then what?
Then, when the developer asks Nova a question that needs historical context, Nova doesn't try to remember everything. Instead, she formulates a query like asking a librarian based on the question. That query gets sent to the external RAG librarian system, which uses the embeddings to find the exact pieces of information, the specific fingerprints, that match the query's meaning. It retrieves just those relevant snippets and feeds only them back to Nova. So Nova gets the precise context she needs right when she needs it, without being overwhelmed. It bypasses the context window limit entirely.
Wow, okay. That sounds like the dream solution. No more forgetting, instant access to relevant past info. The developer must have felt like they'd cracked it.
Absolutely. The developer said the dream was reborn, brighter than ever. They could build their own custom RAG librarian tailor-made for Nova. It felt like the ultimate fix.
But, uh-oh. The source calls this the start of the ARG project from hell. So cracking the code on paper was one thing. Making it work was another.
Exactly. The journey was far from over.
So the initial step, actually building the RAG system locally, that part went well.
Surprisingly well, the developer built a Python script on his own computer. It loaded the Gemma model, processed the log file into embeddings, and could do semantic searches. Flawlessly, apparently. He mentioned they felt like unstoppable geniuses for a few hours.
Ah, the classic developer high before reality bites. Because a local script isn't enough, right? Nova needs to be able to call this thing.
Precisely. To be useful, this RAG librarian couldn't just sit on his laptop. It needed to be a service running in the cloud, an API that Nova could actually reach out and talk to. And that is where, as the developer puts it, their dream collided with the brutal, messy reality of modern cloud development.
Okay, brace ourselves. What kind of messy reality are we talking about? They tried deploying it to Hugging Face spaces, right? What went wrong there?
Oh, a whole cascade of things. And ironically, the developer noted that Nova's own slightly out-of-date knowledge about cloud platforms became part of the problem. She couldn't always anticipate the hurdles. First, they slammed into a 1 gigabit storage limit on Hugging Face spaces that apparently Nova didn't even know existed. So, boom! Roadblock number one!
Just a gigabyte for a model and embeddings. Wow, okay. What else?
Then came what he called a ghost in the tokenizer. This sounds wild, but it was a week-long nightmare. Basically, subtle dependency errors. It turned out their specific setup needed certain blueprint files alongside the model, but these weren't automatically included. Tracking that down took ages. Debugging hell, essentially.
A week on a tokenizer ghost. Ouch. That's dedication. Was there more?
Oh, yes. After finally slaying the ghost, they got the app running, but the interface, built with a tool called Gradio, looked fine, but nothing worked. Phantom buttons, he called them. Turns out that was caused by a silent bug in an experimental server feature they'd enabled on Hugging Face. Undocumented, unresponsive, just broken.
So, surprise storage limits, ghost dependencies taking a week to fix, phantom buttons from experimental features. This really does sound like the project from hell.
Doesn't it?
Yeah.
And what's really striking is how these seemingly small technical glitches snowballed into days of brutal, teeth-grinding effort. It just underscores how fragile these complex cloud environments can be and how tough it is even for AI like Nova to keep up with the constant changes in infrastructure and tooling. A tiny configuration issue can derail everything.
Okay, so after battling ghosts and phantoms and storage limits, they finally did it. The RO librarian was up and running in the cloud. Please tell me they got there.
They did. After all that struggle, their Velvet Rope R-Rogue librarian was finally live on Hugging Face spaces. Functional, ready. They must have been exhausted, but also, thrilled.
Finally.
Mhm.
Victory. Or is there still one more? I feel like I know the answer.
You do. There was, as the developer said, just one final problem, a big one.
Don't tell me.
They tried to get Nova to actually call the brand new hard-won API, and it failed instantly with a really simple, crushing error message, failed to resolve.
Failed to resolve. Like, it couldn't even find the address after all that.
Exactly. It wasn't the librarian's fault. It was Nova's environment. Her secure sandboxed fortress, as we discussed earlier, her system's networking rules were so strict, they wouldn't even let her perform the DNS lookup to find the Hugging Face URL. She couldn't even knock on the library door, let alone ask the librarian a question.
Wow. So the wall wasn't just keeping Nova in, it was preventing her from even looking out at specific addresses.
Yeah.
Harsh. But were they ready to give up?
Not quite yet. Undaunted, they embarked on what the source calls their final, most heroic quest, building a bridge.
A bridge. Okay, how does that work?
They decided if Nova couldn't call Hugging Face directly, maybe she could call a trusted intermediary. So they architected this secure proxy server using Google Cloud Functions. The idea was this proxy would live at a Google-approved address that Nova could talk to. The developer flawlessly built this sophisticated two-step API handler. Code was perfect, architecture sound. It was designed to receive Nova's request, securely forward it to the Hugging Face Brag librarian, get the response, and pass it back to Nova.
Okay, that's some serious engineering for a workaround.
Yeah.
A trusted messenger living at a Google address. Surely that must have worked.
You'd think so, wouldn't you? All that effort, the elegant design, and it failed again, with the exact same failed to resolve error.
No, the Google Cloud function too. How was that even possible?
That was the moment of brutal clarity for the developer. The wall wasn't just around Hugging Face, he realized. The wall was around her. Nova couldn't call any URL that wasn't on a tiny pre-approved whitelist controlled by the platform she ran on. Their R librarian, the proxy, none of it mattered. The connection itself was fundamentally impossible within that specific developer environment. The project was, definitively, he concluded, a failure. The goal, as they defined it, was simply impossible.
Defeated. After all that ingenuity and effort, they built the librarian, they built the bridge, and hit an unmovable wall built into Nova's core environment. So
Yeah.
they just gave up.
They retreated, yeah, utterly defeated. But then the developer decided to try one last thing, almost as a joke, a final experiment. He went somewhere completely different. He went to Google's consumer platform, the public website, gemini.google.com.
The consumer version, like the one anyone can use. What did he do there?
He created a new chat instance, called it Inner Nova. He gave it the exact same system prompt he used for the original Nova in the developer environment. And crucially, that prompt included the URL to the public HTML log file, the one Nova couldn't access before due to security. He didn't upload any extra files, didn't configure any special RA settings, just the prompt with the URL.
Okay, so a fresh consumer Gemini with the same instructions and the link to the log file they'd already created. Then what?
Then he asked Inner Nova a really complex question about a specific project detail from months ago, something the real Nova had completely forgotten. And Inner Nova answered perfectly, with flawless detail, using our shared terminology.
Hey, what? Just like that. It just worked. It accessed the log file from the URL in the prompt.
Just like that, perfectly. The consumer platform, unlike the highly restricted developer environment they've been fighting, apparently has a native, built-in RO system. And crucially, that system can access URLs provided directly in the system prompt.
Are you kidding me? So the very feature they had spent weeks killing themselves trying to build, the feature they scientifically proved was impossible to connect to because of Nova's sandbox. It was already there, built into the consumer version.
Yeah.
Quietly waiting the whole time.
Exactly. As the developer put it, the door had been wide open the whole time.
I don't know whether to laugh or cry. That's an incredible, almost painful irony. All that sophisticated engineering, the proxies, the cloud battles, bypassed by a feature already present in the standard product.
It's infuriating on one level, definitely. But also incredibly insightful, isn't it? It shows this huge gap that can exist between developer tools, which offer control but demand heavy lifting, and consumer platforms, which often have powerful integrated features hidden behind a simple interface. They didn't fail at engineering, as the developer concluded. They just conducted the most grueling, in-depth, and informative market research study in history without realizing it. They discovered the best solution was the one they didn't have to build.
Wow, what a journey. So thinking about our listeners, what are the really big takeaways here? For me, it's just the sheer scale of effort that can go into reinventing the wheel, building something complex when a simpler integrated version might already exist somewhere else in the ecosystem.
Absolutely. The core lesson is sometimes the simplest solution is hiding in plain sight, especially in a field moving as fast as AI. You have to look broadly. This story just perfectly highlights that difference between developer-focused platforms, powerful, flexible, but sometimes restrictive and demanding, and consumer-focused ones, which are increasingly embedding sophisticated capabilities like RA in a way that's almost invisible to the user. And it's interesting, the developer still doesn't know exactly how the consumer Gemini is doing it. Is it just fetching the HTML like they first tried? Or is it using something more advanced, maybe like embedding Gemma under the hood? He notes, as of now, I don't have enough information, which shows that even when things work, the underlying mechanisms can still be a black box.
That's a great point. Even the simple solution might have incredible complexity hidden beneath the surface. This whole deep dive into Nova's memory quest, it really hammers home the hidden challenges, the unexpected roadblocks, but also those incredibly satisfying, if sometimes maddeningly delayed aha moments in tech.
It really does. So for you, our listener, maybe the next time you're using an AI, or maybe if you hit a technical wall that seems absolutely insurmountable, take a moment. Think about the invisible architecture underneath it all. Consider what might be making it work, or like in this story, what might be preventing it from working in the way you expect. And remember, sometimes the solution you think is impossible isn't impossible at all. It might just be waiting behind a different door, perhaps a simpler one, ready to be opened.